Hi, everyone. Welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 100,000 computing professionals and students who are ACM's members. I'm Vicki Hansen, and I'll be the moderator for today. I'm an ACM Fellow, and I've been involved with ACM for many years in a number of volunteer capacities. Currently, I serve as the ACM Vice President. I'm the past chair of SIG Access, which is ACM's special interest group on accessible computing, and I was the co-founder and for several years the co-editor-in-chief of ACM's Transactions on Accessible Computing. I'm a distinguished professor at the Rochester Institute of Technology and the B. Thomas Golisano College of Computing and Information Sciences. I'm also chair of Inclusive Technologies at the School of Computing at the University of Dundee in the UK, and I'm a research staff member emeritus from IBM's T.J. Watson Research Center in New York, where I founded their accessibility research group. My own research is in the areas of human-computer interaction and accessibility, looking at applications of technology to serve the needs of aging users and people with disabilities, looking in particular at issues of language, cognition, and healthcare. You can find my full profile in the bio widget on the left side of your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. For those of you who may be unfamiliar with ACM or what it has to offer, you can see some of the highlights on your screen here. Before we get started, I'd like to quickly mention a few housekeeping items shown in the slide in front of you. The slides will advance automatically throughout the event. On the bottom panel, you'll find a number of widgets and resources. In particular, I'd like to point out that this webinar is being captioned, and the bottom panel includes a closed captions widget to access these captions. If you're experiencing problems with the slides or audio, press the F5 key in Windows, Command R if you're on a Mac, or refresh your browser on a mobile device. Alternatively, you can close and relaunch the presentation. To control volume, adjust the master volume on your computer. At the end of the presentation, we'll have time for questions. Please type your question into the Q&A box at any time and click on the Submit button. You don't have to wait for the end of the presentation to submit your question. This session is being recorded and will be archived. You will receive an automatic email notification when it's available, and you can check at learning.acm.org in a few days for updates. I already mentioned the widgets panel. You can use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag ACMWebinarAccess. Today's presentation is Making the Digital and Physical World Accessible for People with Disabilities, and our speaker is Eve Andersson. Eve leads accessibility engineering at Google. Before joining Google, she was Senior Vice President of Academics at Neumont University. She also co-founded ArsDigita Corporation, which is an open-source software company that was acquired by Red Hat, and she was Visiting Professor of Computer Science at the Universidad Galileo in Guatemala City. She's co-authored 2 books, Software Engineering for Internet Applications and Early Adopter VoiceXML. As an ACM volunteer, Eve serves on our Professional Development Committee. Her educational background includes engineering degrees from Caltech and the University of California, Berkeley, and an MBA in finance from Wharton. She's based in San Francisco now, but before this, she lived in Argentina, Guatemala, the UK, and various US cities. When she's not managing accessibility projects for Google, Eve pursues interests in travel, photography, the number pi, and she works on her own software projects. Eve, we're looking forward to your presentation here today.
Thank you, Vicki. Hello, everyone. It's an honor to be here today and talk with you about making the world accessible for people with disabilities. It's a topic that's close to my heart, close to my beliefs. I think the world needs more accessibility in it. It's also a really interesting field to talk about, one that cuts across many fields within computer science and beyond. There are so many areas where researchers and companies around the world have made significant progress. And there's so much more innovation to be done that can materially impact people's lives. I have two goals for this talk today. For those of you who are currently building a software product, my goal is to help you learn a little more about accessibility and give you some practical tips for implementing accessibility into your products. For those of you who do research, maybe in academia or in a business environment, I'd like to talk about some research problems in accessibility that have room for further exploration, perhaps by you. First, let's talk about impact. The World Health Organization estimates that 15% of the world's population has a form of disability, and that's over 1 billion people. That's over 3 times the population of the United States and more than the entire population of Europe. So everything you do in accessibility has the potential to affect many people's lives. I assume that all of you care about accessibility, and that's why you're here in this webinar. But sometimes you need to convince a boss or another stakeholder to prioritize accessibility. And so here are some reasons that you can give. First, and most importantly, it's just the right thing to do. I believe that everybody deserves to be able to get a good education with access to the same learning materials and collaboration opportunities as other students. I believe that everyone deserves the opportunity to participate fully in the workforce in their chosen profession. I believe that everyone deserves to be able to communicate with other people, to have access to information, to enjoy entertainment. Secondly, there's a big market opportunity. This can be the next billion users of your product. There's also growing market demand for accessible products. Companies are starting to require accessibility when they're putting out RFPs. It also opens up the ability to get some educational and government contracts. Thirdly, there are regulations and laws in various countries that pertain to accessibility. And lastly, building accessibility into your product can result in a product that works better for everyone. Let me give you a few examples of that. If your user interface has good contrast between the text and the background, that will help users who have vision loss. It'll also help users who are out in bright sunlight trying to use their phone. If your user interface doesn't require a user to aim precisely at a tiny touch target on a mobile phone, that will help users who have a motor impairment. But it'll also help users who are being tossed around in the New York City subway system. If alerts generated by your software, for example, calendar reminders, use modes in addition to sound, for example, visual alerts, that will, of course, help users who have a hearing impairment, and it'll also help people who are using the system in a noisy environment. So those are 4 reasons that it makes sense to always consider accessibility when creating a product. Today we're going to talk about accessibility in both the digital and the physical worlds, but we'll start with the digital world. And the question that I'd like to talk about today is, how can we ensure that websites and mobile apps and other digital content are perceivable and navigable by everyone, regardless of their abilities? Some specific questions that you can ask yourself are, can people use your website without needing to use a mouse? Will they be able to understand what's happening in embedded videos in your site or your app, even if they can't hear? Will they be able to navigate your site or your app with a screen reader, which reads out elements on the screen, even if they can't see? Can they distinguish between elements of the UI, even if they can't see colors? And these are just examples. There are other disabilities to consider, of course, and different degrees of severity. For example, blind versus low vision. For those of you who are new to accessibility, I think I should quickly explain assistive technologies and describe just a few of them. There are many, but just a few so that you understand them concretely. Assistive technologies are software or hardware that helps a person with a disability use a device or its applications or its content. And some assistive technologies are built in to the device, like the mobile phone. Some can be installed as software on top of it, and some require external hardware. So let's look at a few. So a screen reader lets people hear the content of the screen and interact with it and get audio output. They're mostly used by people who are blind, but there are other use cases also. For example, for people for whom reading text is difficult. On modern smartphones, screen readers are built in. You can try your own phone screen reader, but please not now because I think it'll distract you for the rest of the webinar. On iOS, the built-in screen reader is called VoiceOver, and on Android, it's called TalkBack. For some desktop operating systems, there's a screen reader built in. For example, Macs have one that's called VoiceOver, just like the screen reader on iPhone and iPad. Chrome OS also has spoken output built in. On Windows, the most popular screen reader is called JAWS, but it costs money. There's also a free one called NVDA. A refreshable Braille display lets your computer or phone produce Braille dynamically. And it's a separate device that's connected via Bluetooth or a cable. It can produce Braille characters using these little actuators that are under each pin, 8 pins per character. And each one of these pins can be in the up position or the down position. So some Braille displays, like the one that is showing on the screen here, also have Braille input, so you can type by forming Braille characters instead of having to move your hands all the time between the Braille display and a traditional keyboard. Magnification is something that's typically built in to both mobile and desktop devices. It lets you zoom in and out really easily so that you can zoom out to get the big picture and zoom in to see the detail. A hardware switch lets people who have a motor impairment operate a computer or a mobile device. It could take the form of a button that you might push with your hand or your arm or even your head, or a foot pedal, or there's something called a sip and puff device that can send signals to a computer when someone inhales or exhales. I don't have a picture of that on this slide. Or even what Stephen Hawking has, which he has a device attached to his glasses, and it detects movements that he makes with his right cheek. There are many other assistive technologies. There's Dragon Naturally Speaking. Some of you might have used it. It lets you do voice input and control on computers. And I actually used it quite a bit myself when I had carpal tunnel syndrome. There's eye tracking software. The list goes on. But I hope that this just gives you a flavor of some of the types of assistive technologies that are out there. Before we talk about research in digital world accessibility, I'd like to start with just a few practical tips that you can make use of today to make sure that your website or your app is accessible. This will give you an idea of the types of things to consider. A webinar, though, it's a bit too short of a format to give you a comprehensive list of everything you can do. But we can get started, talk about a few things, and then you can follow up on your own. There are many resources online for learning more. The first tip is to make sure that all images are labeled. On the web, this is called alt text. On Android, it's a content description. In this image I'm showing, it's a screenshot of a game with the scores that the user got. And there's a share icon beside it. And if this share icon weren't labeled with something like share your score, then some users wouldn't know what the icon is for, because the screen reader wouldn't necessarily recognize that that image is typically used to mean share. The second tip is to make sure that there's enough contrast between the foreground text and the background of your web page or app. For normal-sized, non-heading text that's in the body of your page or app, the contrast ratio between the text versus the background should be at least 4.5 to 1. And for large text like headers, it's okay for it to be a bit less. 3:1 should do. There's a really useful online tool. It's by WebAIM. It's an online color contrast checker, and you can just use it for free. You just enter the text color and the background color, and it will tell you what the contrast ratio is. The third tip is to make sure that people who can't hear the audio content always have an alternative. We're all familiar with captions on videos, and make sure that any videos you've embedded in your site or your app have them. There should also be transcripts for things like podcasts and other audio content. Think also about visual indications of alerts. For example, let's say you're building a video game and you want to give a 10-second warning that the level is ending. Try to do so with both visual as well as audio indicators to make sure that everybody is able to get the message. The fourth out of 6 tips that we'll talk about today is to not rely on color alone, because some people are colorblind or they don't see at all. And I've seen a lot of over-reliance in colors in certain places. For example, this little screenshot I have up here, status reports and dashboards. They often have red, yellow, and green to indicate, for example, on track, slipping, or not started. And there's often not text indicating what these colors mean. And so somebody who can't distinguish the colors isn't going to be able to see the difference at all. Same thing with heat maps. Also, error or warning messages. Sometimes they use the color red to indicate that they relate to a problem, but they don't actually say error. And so somebody who can't tell that it's red won't know that it's a problem. Also, indicator lights on devices. For example, if charging status is shown in red and fully charged is shown in green, then some people won't be able to distinguish the difference. The fifth tip is to make sure that people who don't have completely perfect aim or narrow svelte fingers can use your mobile app by making sure that the touch targets are large enough. And large enough typically means at least 48 by 48 DPs, or density-independent pixels. And I say density-independent pixels because those don't get bigger or smaller for people who have different screen resolutions. It's constant across devices. And the last tip for today is to test your application. Test it with the sound turned off. Test it with accessibility services turned on. For example, large text, to make sure that the formatting isn't messed up when the user changes the text size, to make sure it flows in a natural way. Also test it with the screen reader like VoiceOver or TalkBack turned on. And of course, testing with real users and with disabilities is vital to make sure that you get their point of view. So we've just scratched the surface. There are a lot of other things to think about. For example, you want to make sure you have a reasonable tab order on websites for people who navigate the site with a keyboard. And you want to make sure you have a logical structure of headings, because people like to be able to jump down between H1, H2 headings on websites, etc., in a logical manner. It makes it more efficient for people. Just having access to the content is not good enough. It has to really be efficient and usable. So I gave you those 6 tips, and really I'm just giving you a taste of what accessibility means in practice. The most widely accepted standard is WCAG 2.0, and that stands for Web Content Accessibility Guidelines. And despite this name, it's also highly relevant for mobile apps. In fact, if you do a search, you can find that there is a published mobile accessibility mapping, and it explains how this standard applies to mobile apps. There are many online resources, courses, written developer guides, etc., for web, Android, and iOS accessibility. And so instead of biasing you towards specific resources, I'd recommend you do a search, and you'll find plenty of them. Now that we've spoken a little bit about what you can do to make your own sites and apps accessible, let's talk about some areas of research and development. And we'll start again with the digital world before we talk about the physical world. Scene description is about automatically identifying the objects in an image and describing them in a human understandable way. In fact, I think this might be the week of scene description because there have been multiple announcements by various companies. So Wolfram just announced in a blog post on Wednesday the image identification project, which does scene description. And if you get a chance, read that blog post because it's extremely interesting. It just explains how Wolfram went through these various thought processes when developing the system of image identification. Baidu, which is a Chinese search engine, they also announced something this week. There was also research published on the Google Research blog, and it described a machine learning system that combined computer vision and language models as opposed to having two different systems. And this picture on the slide is from that. The system automatically described the image as two pizzas sitting on top of a stovetop oven. I was really impressed when I saw that because I know this is a really hard computer science problem. But I showed it to my husband, and he said, well, you know, it didn't notice the wine glass in the middle of the picture. And I guess that's true. So there's still a few limitations to overcome there. So this is very promising research, though the blog post did show some examples. In fact, the blog post from Wolfram and from Google showed some examples where recognition wasn't as accurate as in this example. So there is a ways to go. Scene recognition has the potential to identify the meaning of unlabeled images on sites and apps so that for people who need an image description, they can be described automatically, even if the developer forgets to label the images. That's the kind of potential this has for making the digital world more accessible. This could also be taken one step further to automatically describe scenes in videos and to do some form of video description. There might be limits in how far this can be taken. I remember watching Star Trek Into the Darkness with some of my colleagues, and we all got these devices that the movie theater provided that do audio description. These devices are for blind moviegoers. And it gave pre-recorded audio descriptions like, and I'm making this up by the way, but similar to, Captain Kirk raises his eyebrows pensively with a look of sadness in his eyes. And it's hard to imagine automatic audio descriptions getting to that point. In scene description, it will be really important to also take into account context. There are nuances in how the images need to be interpreted. For example, this icon that I'm showing here, which is a triangle pointing right, does this icon mean play or does it mean next? And it's entirely context dependent. Another really interesting area in digital world accessibility is automated accessibility testing. And this is an area where a lot of work has already been done, but there's more that can be done. And some of the areas in which further work can be done are not that straightforward. I think they could use some very interesting technologies. So just as background, there are some tools out there that let you automate some fraction of accessibility testing. For example, if you're testing a website, there's the Accessibility Developer Tools plugin for Chrome or FireEyes plugin for Firefox. And for Android, there are various things like Android Lint, which will give you some warnings. There's some public utilities for a piece of testing software called Roboelectric, which a lot of people use to do testing, general testing, not necessarily accessibility specific of their apps. Tools like this are really helpful. They can catch issues like missing alt tags on images or insufficient color contrast or problems related to the tab order for people who use a keyboard to navigate through a page. They can make sure the page has a title, things like that, things that are fairly straightforward. But it's still necessary currently to do manual testing for things that require human judgment. And I'll give you two examples of places where maybe through technology we can lessen our reliance on human judgment. The first example is if you want to check whether all of the images in a web page have a meaningful alt tag. So you don't want to just check that there is an alt tag. For example, a developer could have made to do be their alt tag because they know they have to add one later. And they might have added that so that they stop getting warnings from their testing tool. But that's not really a valid alt tag. So my question is, can we use machine learning to replace or augment human judgment some of the time? So going back to the scene recognition we were just talking about, what if we could compare the alt tag for a given image with the scene recognition results, maybe with various high probability scene recognition results, and see if they semantically match? The second example is, let's say that you want to make sure that all of the interactive elements on your web page can be executed by a screen reader. Sometimes when developers use generic HTML elements like divs and spans to represent interactive elements like form buttons, a screen reader or other assistive technology might not know that the element is supposed to be interactive unless it's been explicitly marked up to say that it's interactive. So my question is, can we use analytics based on real usage of a site or app to know what functionality should be present, and then automatically test whether that functionality is reachable? It's worthwhile questioning our assumptions of what can be automated and what can't. The more manual testing we can replace with automatic testing, the more software developers will be inclined to test their code for accessibility. We just have to make sure that we do the automation really well and that we don't produce false positives. I just want to be extremely clear that I'm not advocating getting rid of user testing. No matter what automatic or manual processes are used to test software, the real user perspective is essential. Another area that's important for information transmission is graphs and charts. You can give people access to the underlying data, but that's not a perfect substitute for letting them access the graph itself, because graphs are really valuable for helping people understand trends and anomalies in the data. And so there are different ways of tackling this. There have been several research teams and companies that have looked at a few different things. For example, graphs can be printed using a Braille printer. And a Braille printer prints raised dots. But the resolution's not that great, and so the shape that's formed by these graphs, it's not continuous, and so it's not perfect. Graphs could be printed with a 3D printer. I haven't seen a streamlined solution for this, and it's slow, but it could work. But I wonder, is there some way to print that's not wasteful? Some way that the materials could be reused for other graphs? There have also been multiple research papers on auditory graphs. An auditory graph, it changes the pitch based on the Y value in the graph. And so that can help you experience the trends and the anomalies in the data. And there is a video that you can check out later on YouTube by the Sonification Lab, which is a research lab. And it demonstrates someone exploring a graph with their finger, hearing the different pitches in the graph, and then whenever they desire, they can have the actual X and Y coordinate values read out to them. And this seems pretty promising. There's also research around haptic representation of graphs. And haptic just means relating to the sense of touch. I've seen work related to using a device that's called a phantom haptic device, and even using forced air to give this representation by touch. but I haven't yet seen anything viable on mainstream technology like a smartphone. But I can imagine, for example, strengthening of haptic feedback as your finger approaches the lines drawn on a graph, for example. People have also worked on automatic trend and feature description of graphs. So a trend would be something like revenues increasing exponentially. And a feature would be something like there was an outlier in daily revenue of $3 million on March 14th. And that seems like a promising way to automatically give graphs alt tags. But because some information is lost when only describing a graph, the user would ideally also be given a way to explore the data points and retrieve the XY coordinates whenever they desire. So we talked about a few different areas of research in digital world accessibility. Of course, there's so much more, but those were a few problems that I think are really interesting and where there has been some significant research and where I think there's still room for more. So now let's shift our direction a little bit and think a bit about physical world accessibility. And the question we're trying to answer here is, how can we use technology to make interaction with the physical world easier for people with disabilities? And some of the areas where technology could be useful include, for example, identifying objects in a person's physical surroundings, which could be useful if they can't see the objects or if it's hard for them to physically get to them. Second, enhancing people's ability to communicate with other people. Third, getting around physically, so transportation and navigation. Also interacting with appliances and other objects. And there's so much more. Going back to object recognition. So that's about identifying objects in your surroundings. So for example, you might want to know what color is the stress? What are the ingredients in this box of cereal? What flavor of hint water are you drinking or about to drink? What temperature is the thermostat set to? And there are some apps that already exist for this purpose. Be My Eyes is an iPhone app through which sighted volunteers can describe things to blind users. It's extremely popular. When I ask blind people I know which app they like the most, Be My Eyes is almost always towards the top of their list. Engineers shouldn't forget crowdsourcing as a source of innovation. Innovation doesn't always have to be purely technical. TapTapSee is another app for both iPhone and Android. It recognizes objects through a combination of vision and computer vision and crowdsourcing. I've seen a video where it can identify currency amounts and food packaging labels in seconds. This video was by Tommy Edison, who's a blind and pretty charming, in fact, video blogger. And he was so impressed by TapTapSee that he, I think jokingly, asked, "Who needs sighted people?" And going back to the scene recognition that we talked about earlier, I think we're getting to a point now where the GPUs, the graphical processing units in mobile devices, are getting so good and so fast that I think before long we will see real-time on-device description of scenes and objects around us. Moving on to American Sign Language, so also known as ASL. This is the primary language used by deaf people in North America and some parts of West Africa and other geographical pockets around the world. And there are quite a few different areas of research around ASL. One area is video compression that's optimized for ASL communication over mobile networks. And this is really relevant because slow network speeds can make it difficult to properly see the signs made by the person you're communicating with. There's a project called Mobile ASL with joint research done by the University of Washington and Cornell that has made advances in this. Even though mobile networks are getting faster in many countries, There are still periods of slowness, as I'm sure we've all encountered, and in developing nations, this would be particularly relevant for helping people communicate through sign language on mobile phones over slow networks. Another highly impactful but extremely difficult area of research is in automatic sign language interpretation, which means automatically translating ASL into spoken or written language. Also, automatic sign language generation is an area of research. And these two things would enable somebody who's deaf to more seamlessly communicate with somebody who's hearing. This is a really complicated problem, much more complicated than I think most of us know until we really start to dig into the details. Signing uses a lot of the body. It's not just the hands, it's the arms, the torso, the face. It uses movement. The grammar is completely different from the grammar of English. Signs can be ambiguous. They might not be unique. It incorporates a lot of context and so on. So it is a pretty hard research problem. I've seen some systems already that can interpret and generate a limited corpus of phrases. And they can do finger spelling, which is spelling out letters one by one. But I still haven't come across a comprehensive solution. When and if that happens, it really has the potential to be a game changer. Let's talk about navigation in the physical world, which combines a whole bunch of different areas of research and development into solving one big problem. So imagine that you're trying to get to point A in building A to point B in building B. And if you're not familiar with the journey, you might want a system that helps you navigate that route in the best way for you personally, taking into account any disabilities or any constraints that you might have. And there are many technologies, some are full-fledged, some are more emerging, that put together could form the basis for this. One thing you need to be able to get this right is precise three-dimensional indoor maps. And there have been such maps created using a Kinect. Also with the Project Tango phone. Project Tango is a collaboration between Google and a bunch of other collaborators. And both of these devices have depth cameras in addition to standard cameras. And I think this piece of the puzzle, indoor 3D mapping, it's fairly well solved compared to other parts of the puzzle, but it's still a bit cumbersome to create the indoor maps, a bit time consuming. So the system also has to know precisely where the user is within an indoor space, so the localization problem. And this is especially essential if you can't see the space around you and autocorrect yourself. A difference of 1 meter could mean the difference between entering one conference room and entering the next conference room. And there are various techniques for doing localization indoors. Wi-Fi triangulation is one technique, but there are more accurate methods. There have been several research papers about visual odometry, which is using camera images and feature detection to determine a person's location. Project Tango uses visual inertial odometry, and that combines visual odometry with inertial motion sensing, by which I mean rotation and acceleration sensing, as well as with drift correction for even greater accuracy. Next, we have pathfinding. The system needs to be able to find the best path for the user, taking into account constraints such as avoid stairs. In real time, also, it should be possible, at least in theory, to use computer vision to detect obstacles and then warn the user or reroute them if necessary. Of course, the user interface needs to support users with different needs by being able to give feedback that is visual, auditory, haptic, or some combination thereof, depending on the user's preferences. And these pieces that we've just talked about, Those are about individual navigation, so moving oneself from point A to point B without a vehicle. But now, what if we can combine that with autonomous vehicles, self-driving cars? And I think autonomous vehicles are really at the cusp of becoming a commercial reality. There are just so many companies and organizations working on it. I even saw an announcement last week for a self-driving commercial truck called the Freightliner Inspiration Truck. And I don't know how self-driving it is, because I think there are different shades of gray in the word self-driving, but I think it's pretty interesting. So depending on the direction that industry and lawmakers take with autonomous vehicles, this could be a really valuable point of integration with an individual navigation system. A system like this could help increase independence, and it could make people more comfortable navigating the physical world. The last thing I want to just touch on is the Internet of Things. And I know this is something that people have been talking about for a long time, and I think it's really, there are interesting and great things emerging now. It's emerging really quickly, and it has implications for accessibility. With the Internet of Things, all kinds of devices and products, even your pet dog, can be connected to the Internet. And the Gartner Group, which is a research group that makes quite a few predictions, they estimate that nearly 26 billion objects will be connected to the Internet in 2020, just coming up very soon. And already today, there are implications for accessibility. Connected devices can be easier to use than non-connected devices in some cases. For example, you can turn on your Philips Hue light, unlock your door, set your thermostat from your phone. And this could be easier than interacting with physical devices if you have some kind of dexterity disability or even visual. Looking forward, I think products will be tagged, individual products. And it's going to make it easier for you to identify objects so that you can tell the difference between your bottle of Zinfandel and your bottle of Cabernet Sauvignon. Thinking a little bit more futuristically, this could help, a tagged object could help a robot identify an object to bring it to someone. Also thinking futuristically, sensors will become so cheap that a sensor in your body will be able to detect that you've taken a pill that has its own sensor embedded in it. And this will help people with memory loss, for example, know if they've already taken their pills. This field is so new, and I'm really looking forward to seeing how it develops and how we can benefit from it in terms of accessibility. So those were just a few areas of research related to making the physical world accessible. And I want to leave time for questions, so I could have talked about other ones, but I'll see what questions come up. I'd like to thank each of you for coming today. For me, it's a big honor to be able to work on accessibility and to be able to share a few things with you today. And I'd like to thank you for any part that you play in the past or going forward in making the world a more accessible place. Now I'd like to open up the floor for questions, which Vicki will moderate.
Thanks, Eve. That was really great. A lot of useful background information and some real insights into where the field is going. So thank you very much. Right. So moving on to questions. We've had quite a few come in. They're coming in fast and furiously now. For the first one, this goes back to the very beginning of your presentation, Eve, and is asking if you can suggest some good resources for referencing for clients when the clients might initially say something like, we don't have any blind users.
Yeah, I think in this case, there are a few arguments that you can give to your clients. And, you know, whenever talking to people to try to encourage them to think about accessibility, it's really important to understand their motivations and what's going to convince them. And so for some clients, I think the doing accessibility is the right thing argument is really valuable, whereas for others, laws are more important for them. But I think they need to think about the users of the product, and there might not be any blind users today. But if you don't make it accessible, then you're preventing people from using your product. And what a pity. What a pity for the people who would want to use it. What a pity for your market. Your product won't be able to be used in education as well, probably. And, just don't only think about today's users. Think about tomorrow's users, too, and being inclusive of everyone.
Okay, related to that, I think, is a question that just popped up, asking if you think that user experience design is different when you're designing for people with disabilities than when designing for a mainstream audience.
I think it's extremely interconnected. And I did give the example of, for example, if you're designing for people with a visual impairment, for example, with low vision, then making an application that has sufficient contrast is also going to help more mainstream users when they're in a situation where they're not able to see as clearly, for example, bright sunlight. And I've actually myself, I don't think that I have a visual disability. However, I do find myself using magnification on Android sometimes when developers have failed to make their fonts adequately big. So there is crossover. I do think that when you are doing design, it's important to involve people with disabilities explicitly, because there are some places where they might have some needs that other people might not have. And a really good technique for doing design is early on is what's called a cognitive walkthrough, where you are talking. You don't even have to have a prototype built, but you're talking with a user with a disability and talking through the flow out loud with them and seeing how they react to that. So to answer the question, really, it's a combination, but I do feel that when people step back and think about all types of users when they're designing their apps, it really does cause them to think about things in different ways. One example of a technology that one of my colleagues mentioned to me, I think it was last week, auto-completion when you're typing on an on-screen keyboard, auto-completion of words. That was originally designed to be an accessibility feature. And now I can't imagine living without it. So really there's more overlap than people think.
Yeah, great answer, thank you. You mentioned Stephen Hawking at one point, and someone's asking if you know of other new developments in communication devices or solutions for people who cannot speak.
Well, there's switch access, and of course Stephen Hawking's his device is an example of a switch, and switch access can allow for fairly full control of a computer or a mobile device. I know that Apple has it, Android has it, and I'm not as familiar with the solutions for PCs, but I have seen people use it, so I know it exists. And really, I think the most valuable thing is to be able to give full access to these mainstream devices, as opposed to building specialized hardware in many cases, unless it's really needed. But, the thing is, maybe, I don't know if Stephen Hawking likes Facebook or not, but a lot of people with disabilities, they want to use exactly the same things that other people are using. They want to communicate with their friends via Facebook and via WhatsApp and all kinds of things. And so giving people access to the same types of hardware just through this assistive technology, I think, is one of the most impactful things that we can do.
Okay, thank you. There have been several questions. The questions are coming in fast and furiously, by the way. There have been several questions about older adults, so just trying to put them all together into one general question. Is there something that you could say about specifically designing for that population that might be in addition to or different from the kinds of design principles you talked about throughout your talk?
Yeah, I actually see this quite a bit. In fact, both of my parents are starting to have some vision loss. My father is starting to have, well, he has for a while, starting to have some hearing loss. And so this is really close to my heart. And what's interesting is that a lot of this applies to them as well. In fact, just last week I was able to give some advice to my dad about which phone to get for my stepmom because she doesn't read the screen as easily as she used to. So I think there are a few different things. One is, of course, just making sure that the text can be expanded to reasonable levels, pretty big, to making sure there's very good contrast, making sure that you don't rely on audio too much. Another thing that we didn't touch on at all is simplicity of user interfaces. And I think that can be extremely powerful for a variety of people, for older adults, for people with cognitive impairments, for people with memory impairments. You know what? Even for people who are multitasking, because that really simulates a cognitive impairment. And so having fewer things on the screen at the same time in a more streamlined way of accomplishing a task, instead of only thinking about the power user who wants to be able to do 100 different things from one tiny screen that's 5 inches across. I think thinking about that kind of design, maybe having different options in the software for people who like different user interfaces, I think can be really valuable. One feature of Android that I really like, a development feature, is that there's a whole system of intents. And it means that any application can expose its API. And so if you don't like the user interface of an application, as long as it has these intents and content providers, which is another portion of the API that an application can expose, you're able to create your own applications with a different user interface on top of it. And so this can also be a way of creating something that meets different people's needs. You can almost have customized software that meets one person's needs instead of trying to think about users as a group, because each user it's a diverse set of people, and maybe one person's needs are completely different from another person's needs. So it's nice to have this flexibility. Now, Vicki, you're the moderator, but you are also a well-known expert in this field. So do you want to also give a few comments in response to what the participant asked?
Thanks. I'm busy reading questions here. I think you hit on the key points. Simplicity and consistency are very good. So it's not just a matter of putting a little bit on a screen, but it's a matter of, if you've got a website, for example, consistency from page to page. That helps with the cognitive load. And the cognitive load is, I think, one of the major issues with aging. There may be other things going on too, but the cognitive load, I do believe, is a major one. I will.
That's a really good point, Vicki. And
yeah. Sorry? Okay.
Sorry. We got crossed in transmission. Another thing that I forgot to bring up is the dexterity impairments such as arthritis that become more prevalent as people age. And it becomes harder to aim for these tiny touch targets on screens. And so making sure, I gave the recommendation for 48 by 48 density independent pixels for each touch target, making sure that these targets are big enough so that somebody who it might hurt them to have to try to aim at these very small areas. And so keeping that in mind as you design your applications. Also, using a mouse can be painful. And so when you're creating a website, thinking about how to allow for users to do things in multiple ways and not rely on using a mouse, for example, to drag and drop. There should be some alternative to that workflow.
Yeah, I think what you're really highlighting in the answer, since this was a very long and complex answer, is that the issue with older adults is that there's often many interacting issues going on. So, there may be some issues with eyesight, there may be some issues with dexterity, and there may be some cognitive issues. So it's not simply a matter of addressing one or the other, but the complexity of the issues together. Because with the complexity, any one issue is likely more severe than it would be by itself. That makes sense. So if you have low vision and a cognitive limitation, the low vision issue becomes worse in some sense. So
yeah,
I think
that's a really good point.
Designing for older adults is how do you think of many interacting issues? Okay, ready to move on? Got many more questions here. Okay. This one's a challenging question, I think, so I'm looking forward to hearing what you have to say. This is from a blind person who is a programmer, and he had a very interesting question saying that he has trouble coping with code that goes on for hundreds of pages because he can't get a holistic view of the code. Do you know of any ways around this to help get a more holistic view of what's happening?
Yeah, that's a really good question and a hard one that I don't think I actually have an answer for it. I do know quite a few blind software developers, and it's hard. Even with a pretty good Braille display, you might only be able to read 40 characters at a time. And so I don't know any technical workarounds for this to get the holistic view. I think there might be some social workarounds, by which I mean if you're working as part of a team, helping other people on the team understand your point of view and practice good coding practices. For example, don't have lines that run on for many, many, many characters, and be consistent in coding styles and naming conventions, etc. But no, I don't know of anything great for kind of getting a picture of the system at a glance.
All right, so that sounds like a really interesting future research topic for someone to take on.
It sure is. There's research in summarization, not of code. Now I'm talking about text, which is also extremely relevant for accessibility because you don't want to have to go linearly through a whole page of content to see if it's relevant to you. You want to be able to just quickly, at a glance, so to speak, understand both the content on a page or an app and also the functionality. And so there has been research in summarization. What I've seen has been mainly about content and not so much about functionality, summarizing what can I do on this page. But I think that would be a really interesting area of research as well.
really just about out of time, but I'd like to finish with one last question related to your last slide. Someone was asking if you could elaborate just a bit more on accessibility research topics for the Internet of Things.
You know, I have not heard about external research on that subject. This slide was almost more of me thinking about the implications of things that I've learned about Internet of Things myself. So I think, yeah, I can imagine some of the implications for it, and I'm actually aware of people who are happy because they're able to use some connected devices that they haven't used, things that were harder to use previously. But in terms of actual accessibility research in universities or companies, I'm not aware of any. So if you are aware, if anyone out there is aware, I'd love to hear what you know about this topic. But I do think, given that Internet of Things is really emerging and becoming big, and I feel like this is going to be a really important topic in all of our lives. It's going to change the way that we interact with our physical world around us. I do think that this is a wonderful area for research.
Okay. And thank you. On that futuristic note, I think we'll have to end the Q&A portion of this. So thanks, Eve. This has really been a great learning experience for everyone. Really appreciate you doing this. I'd like to again thank Eve Andersson for the presentation, and a special thanks to all of you who are in the audience for taking the time to attend and participate today.
Thank you so much, Vicki. Thank you so much to all of you who are here participating.
Yes, do appreciate it. And I just want to say this webinar was recorded and will be available online in a few days at learning.acm.org. And there you can also find announcements about upcoming webinars, and you can find out about other ACM activities by visiting acm.org. There should be a survey being shown now. If you could please fill out this quick survey on your screen where you can suggest future topics or speakers. And thank you. This is Vicki Hansen saying goodbye for now. And thanks again for joining all of us, and I hope you'll join us again for future webinars. Thank you.